Hello friends, and welcome to this video regarding memory addressing methods in assembly language programming. So first let me show you what all are the memory addressing methods. Basically you have six types of addressing methods. First one is immediate addressing mode, second is direct addressing mode, register addressing mode, addressing mode, indirect mode, and base pointer mode. So let's discuss in this program the two modes of addressing, immediate and direct. So let's have a program. Sorry. So this is nothing, just a most simplest program. It is having a string called data1, having the characters mark in it. Then you have a simple print routine, printing the contents of data1 onto the screen. Then you have the exit routine. Correct. So let's see it one by one. The first instruction, move L$4 to EX register. What this is doing, this instruction is copying the value 4 into our EX register, not the memory address, just the value 4, numerical value 4 to EX register. This is called immediate addressing mode. Correct. The second, regarding file descriptor, moving the value, numerical value 1 to our EBX register. This is also the immediate addressing mode. The third instruction is data 1 to ECX register. This is actually not moving the or copying the contents of data 1 string to E6 register, but here's the difference. This instruction just copies the address of data 1 string to E6 register for further printing, so that our processor could go to the memory address of this data string and print it onto the screen. So this is called direct addressing method. Correct. Fourth line again, moving the value, numerical value 4 to our EDX register, again immediate addressing mode. Okay, so let's just look onto it through JDB. Correct. Let's make a breakpoint at 10. Let's run. So this is the first line to be executed. First let's check the contents of our EX register. So it is having the hexadecimal value 0x0, that means 0. So let's step through the first instruction. What it does is, let's check it. Okay, so it has copied value 4, hexadecimal value 4 and decimal value also 4 into our EX register. Correct. So the first method clear. Now let's step through the 11th line. Also it is for immediate addressing. Okay, here comes our direct addressing method. So let's first check what is E6 register holding. It is holding 0 right now. Let's step through this instruction and let's check it again. Look, here we have the memory address of our data1. Where is it? Yeah, the memory address of data1. And what is the memory address of data1? Okay, here the contents of data1 string, and here's the address of data1, 8049098, and it is held inside E6 register 8049098. So basically the processor finds some memory address inside this register, and he just straightway goes and accesses this memory address, and whatever the data value, whatever value he gets inside it, he brings it onto the screen with this program. Correct. So let's finish off with this program. Now let me show you. So well, so our first two methods, immediate addressing and direct addressing modes, are clear as of now. So let's move on to register addressing mode. Okay, So register addressing mode is just nothing but data moving into register and moving out of the register is just called register addressing. So nothing special in it. Let's move on to the most important and complex one, indexed addressing mode. Correct? Okay. So here we have in this data section data 1, and it is having a long numerical values inside 10 starting from the 0th. Just remember, for the reference of understanding indexed addressing mode, here the referencing starts from 0. So if I want to if I want you to access the fourth element in this data item, so what will you add to 0? What will you add to the reference? So to the reference you will add 3, because for accessing the fourth element, first you have to go through the first one. First one is referenced as 0, then 1, 2 and 3. So you have to add 3 onto the reference value, so in order to reach the fourth element. Correct? So in indirect indexed addressing method, the reference is always taken from 0. So we have this long data type 10, 11, 22, 33 up till 99. So first of all, what we are doing, so you might remember I think in the first video we had an example of the instructions stow_sl and load_sl. What they were doing, okay, just let's discuss it afterwards. So basically first what we are doing, we have the index number of all these values, index number 0, 1, 2, 3, 4. Correct? So first of all we move the value 0 to our EDI. Fine. Basically we are using EDI as our index register for indexing onto these values, and we want to move to EX register. What we want to move? We want to move 0th element. 0th means the element number 0 means first element from our human reference. So the element number 0, according to machine language, it is element number 0, and we call it first element. So we move first element to our EX register. So this is the instruction. So some part is missing over here. Actually we are not using it. It is considered as 0. So the syntax for using indexed addressing is this one: address or offset, then a register for offset, for introducing the offset, then a register for telling the processor what is the index of the data item which we are trying to access. Then the last one is multiplier. So multiplier is something like, if you have a byte, then you have it as a 1 byte of value, 1 byte of memory. If you have a word, it carries 4 bytes of memory inside it. So basically you multiply these with 1 or 4 accordingly. The result, the last resulting address is, you add address or offset. Addresses or offset is nothing but the starting address of this data item, data 1. Correct? So the address of this one, then the offset that we have introduced with this register, then the index number multiplied with the multiplier. If the multiplier is 2, then we multiply 0 with, or the 0 or 1 anything with 2. If we are using 1, then multiply it with 1 multiplier, or if we are using long type, we'll have to multiply it with 4. Correct? And in the end it is exit routine. Okay, so let's just run it quickly. Okay, just I'll try to make it more fast. I'll pause the video by that time. Okay, while the video was paused, I loaded it onto GDB so that we could save some of our time. Let's list the program. So basically we had to stop at line number 9 so that we could just identify all the things. Create a breakpoint at 9. Sorry, I'll have to insert a no operation, so I'll do that while I pause. Okay, so I inserted a no operation inside the program. See, no op, and let's halt at line number 10. Let's run the program. Okay, right now we are going to just shift 0 value to our inside EDI register. So let's check our EDI register. So it is holding the value 0, correct? So we step through it. Again check it, still it is holding 0. So now let's step through loading the first value in the data items to our EX register. So you remember what is the first value. So this instruction should load value number 10 onto our EX register. Let's see if it happens. So step through it. So let's check it through EX. Okay, successfully it has copied value number numerical value 10 onto EX register. Okay, actually 0xa means decimal value 10. You finish off at 9, then onward 9 onwards 10 as a, correct? So the hexadecimal value of decimal value 10 is 0xa. Okay, so let's see it through. Okay, we got value 10 in our EX register, correct? So let's manipulate some more things in the program. Okay, what if we want to access item number first, actually first from the reference of machine language, if we want to access item number 11. So what we'll have to do, we'll have to create an index number 1 for pointing onto this item, and we'll have to set the multiplier as 4 only. It will remain as same. So let us move number value 1 to EDI. Okay, rest all is well. Let's let me assemble in link. So I have assembled it in the background. So let us list the program. Okay, so we have 1 as our index, so let's halt at 10. Let's run the program. Let's check our EDI before execution. EDI is holding 0. Let's step through. Okay, so now EDI register is holding, index is holding as a value 1. So the index is pointing on to 11, I guess so. So let's step through this instruction now. Let's see what we find in our EX register, correct? So let's check up with our EX register. Okay, fine. So correct, we got our 0xb, that means 11, and we printed in ASCII's, it is value number 11. So we have been able to step through the values inside our data items. Okay, so accordingly you have to move your index. You have to just keep changing your index. For getting value 45, you have to get your index set as 0, 1, 2, 3, 4. Set your index as 4, and that's all. Run the program, you will get the value 44. So in next video, time is up right now. Next video I will show you how to use the offsets. Okay, so bye till then.